Welcome back to this channel for practice problems for actuarial exams. Here you have some information about me. My name is Krzysztof Ostaszewski, and you can find information about me at smarturl.it/Jedi, and I also give you a variety of other smart URLs with link that these sites redirect you to various things that I do, various resources I provide for actuarial exams. I direct the actuarial program at Illinois State University, which you can find at smarturl.it/actuary. If you'd like to make a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help-ISU-actuary. This is our problem for today for exam MFE. You are using Monte Carlo simulation to estimate the price of an option X for which there is no pricing formula. To reduce the variance of the estimate, you use the control variate method with another option Y, which has a pricing formula. You are given the naive Monte Carlo estimate of the price of X has standard deviation 5. The same Monte Carlo trials are used to estimate the price of Y. The correlation coefficient between the estimated price of X and that of Y is 0.8. And you are asked to calculate the variance, a minimum variance of the estimated price of X with Y being the control variate. So the control variate method makes an adjustment to the simulated value of X by having the estimated price X star modeled as the simulated price plus beta times Y true value of the other option for which we have all the information minus Y simulated, where simulated value for that other option Y is calculated using the same type of simulation that we are doing for X. And of course, the expression Monte Carlo, well, it's just there as a name, but it simply means that you're using simulation to estimate the value. So this is the key formula in the control variate method, what you see here. And then we note that the true Y value is assumed to be a non-random quantity existing in the real world, while the estimated and simulated values are random, so that the variance of X star is the variance of the simulated value plus beta squared times the variance of simulated value of Y. Now it's minus Y simulated there. Y true is just a number, so it doesn't matter, it has no effect on the variance, but Y simulated has a minus, but of course the variance of Y simulated and minus Y simulated is the same, minus 2 beta times the covariance of X simulated and Y simulated. And our objective is to minimize the variance of the estimated price of X, so the variance of X star, the left-hand side of what we have here, which is equal to the right-hand side, and we'll work with the right-hand side now to minimize the variance. And we treat this whole expression as a function of the parameter beta. In order to do this, we take to minimize the variance, we take the derivative with respect to beta and try to find a minimum and set the derivative equal to 0. Now this is a quadratic function of beta, considered if it's considered as a function of beta, with a positive coefficient of beta squared, so it has a unique minimum. And so we set the derivative equal to 0 and solve for beta. So we take the derivative, and what do we get? 0 plus 2 beta variance of Y simulated minus 2 covariances of X simulated and Y simulated, and this is set equal to 0. Well, first, from this, beta is equal to the covariance of X simulated and Y simulated divided by the variance of Y simulated. And the minimum variance of X star, the value of that minimum variance, which is what the question asks, is what we get when we plug in this value of beta into the formula for the variance of X star. So we plug it in, as you can see. And what do we get? we get the variance of x simulated minus covariance of x simulated and y simulated squared divided by the variance of y simulated. So if we take the common factor, or assume a common factor of variance of x simulated, then this is variance of x simulated times 1 minus the covariance of x simulated and y simulated divided by the standard deviation of x simulated times standard deviation of y simulated, and then the whole thing squared. And of course the covariance divided by the product of standard deviations, the correlation. And that correlation of x simulated and y simulated is actually given in the problem, and also the variance of x simulated is given. So variance of x simulated is given as 5, and the correlation of x simulated and y simulated is given as 0.8. So we plug in those two values and we get the answer of 9, which is answer D. So the crucial thing in this whole problem is that it does require a little bit of work, but the most important thing is that you know what this technique is. Again, the reminder of it. This is the key formula in the control variate method, the one that we started with. Please remember that this is copyrighted material. Problems from past examinations or practice study notes of the Society of Actuaries belong to the Society of Actuaries and are reproduced with permission. Same is true for problems from Casualty Actuarial Society exams, although this problem is from a study note by the Society of Actuaries. The problem itself belongs to the Society of Actuaries, is reproduced with permission, but the solution is mine. Good luck in your studies and good luck on the test.